Well, look at that. Welcome to March the 27th. It's a beautiful day outside. It's a lovely day to do some electrical work, and that's what I like to do, some of the best things. So I know how to do it. So, here we go. Now we have to get to the 48 volt battery bank here. I'll need to take 48 volts from here to under the sink, because I need it to power this heating element, which is a 48 volt heating element, and it will be turned on with a timer, and I'll be using this relay here, and that is also 48 volts, 100 amps, and I figured that this is 900 watts, so 900 watts divided by 48 volts will give us something like 18 point something amps. So number 12 wire will work on this, and I'll use MC cable. So let's get that started. When you're cutting MC cable sheet from the conductors, you cut at a diagonal till it cuts through one of those. As soon as it cuts through one of those, you can just unscrew it, kind of. And the other thing is, it's really important to put one of these guys in. That's called an anti-short bushing. It stops the cable sheath from digging into the conductor and causing a short. So it's really important to put those guys in. Once you've got your anti-short bushing pushed between the conductors and the sheath, push it down there. Use a special connector here and just push it over everything and snug it in. And then we're going to drill a hole, push that through the hole and put a lock nut on it. Those two terminals there will give us 48 volts, but because the area I'm getting to here is here, I'm going to go in that. I'm going to go put my wire there and bring the conductors round to the 48 volt up there. So I'm going to penetrate this area here and just come up. And then once the hole's drilled, we're just going to push up the MC cable like this. So now we've got the black and red wire going up to the 48 volt source. I have not connected it up yet because I'm not done at the other end. And this is the other end. We've got it pulled up through the bottom of through the chassis area. And I'm going to put that into a box. So we'll come from under the battery area here. We've got a strap on the MC cable, then going off underneath into the kitchen area. So what we've got is 48 volts here. That's coming down to this switch here, and that turns on the power from the 48 volts, and that goes to this relay here. And also from the once the power's turned on, the hot wire then goes up into this timer, which goes down to control the relay. I don't know if you can see that. So when the timer's turned on, this switch closes, and that causes the big power to be able to flow in the circuit. And from there, it goes down into this SO code here, and these two wires are connected to that immersion heater element. But I'm just going to be doing the testing right now. I'm just letting you know what's happening. And like all good electricians, you always put an extra switch in for future. And this switch here, further up, that's just the switch for that pump motor for the water faucet. So next thing to do is we're going to build some kind of wall there, you know, coming out maybe what from here to there, about 8 inches, and that will seal all this in, and that will make it look good. I want to show you a drawing of how I did all this, just so you'll know what's going on. So now we can go ahead and connect that up. Okay, this is the electrical layout of what I'm doing in the motorhome. Starts off with a 12 volt battery here. We've got a switch, a pump, a tap or a faucet, and a tank of water. The way it's connected is you take a wire from here, positive wire goes to the switch is open. When it's closed, it allows electricity to go into the pump. That pump rotates, which causes the water to be sucked out of the tank and pushed out into the faucet or the tap. When this is running, the electricity is running, goes from here, turns the pump, and then goes back to the negative terminal here. So you complete the circuit. Is basically completing a circuit, and that's how that works. Now then, on the next one down, I have to adjust this, excuse me. What I'm using is 48 volts here, using 4 batteries connected in series, and all that means is the negative of one is connected to the positive of the other, the negative of the other is connected to the positive of this one, and then the negative of that one's positive, so it's all positive to negative. When you measure the voltage between that one and that one, you come to 48 volts. So what this circuit is all about, it's taking 48 volts from the battery and it's applying that 48 volts to the load, but you want to be able to control it by turning it on and off and for how long the load is going to be on. So what I did was take a switch here, the positive comes in there, and that switch is open right now. When you close the switch, it allows the electricity to go from here directly down this line to the relay, and from the relay, one side of the relay, at the other side here, it goes to your load, which is the heating element. However, that relay doesn't continue the circuit until there's power applied to here, and that is done by this timer circuit. So from your switch you have both major power going to the relay, I'll say big power, and small power going to the timer. That's the reason this relay is here. It's using a small power to control big power. Now then, the timer, when it's off, does not allow electricity to flow through this leg here. And what this leg does here, it goes to an electromagnet. Basically, it's just a coil of wire, and when you put electricity through it, it turns into a magnet. And that magnet has like a plunger going through the center of it with 2 contacts on the top of it. When you turn the timer on, so it's ticking, it allows the electricity to go in there, energize this coil, and that causes this plunger to pull down because of the electromagnetic force, which closes these 2 contacts here. So the electricity can go from there, through there, and down into your load. You know, then this is the wire to the load. These dotted lines are just show you the outside of the apparatus, like, you know, your timer, your switch, your relay. So that's how it all works. When this timer's off, it doesn't allow electricity to go through the coil, so this plunger here is like on a spring, so it's normally open, and it doesn't close this contact. It's just like a switch basically. Switch, that's a switch, and that's a switch. Most electrical work is all switches, but different applications. So when that is off, the electricity doesn't go down that line, but when you turn the timer on, it allows the electricity, which might be about maybe 1 amp or something like that. That's all you need just to energize this coil. So when that 1 amp energizes this coil, causes it to be an electromagnet, it'll pull that down and allow the big power to go on to the load, which in our case is the immersion heater heating element. So I hope that helps. Okay, it's searching for a voltage. We've got the power hooked up. This is the leads that are going to go to that immersion heater element. Now I've got the power turned on for that. The timer isn't turned on because this immersion heater needs to be on a timer. If you just leave it on, it's probably going to burn itself out once the water runs out. So you put it on a timer. So now what I'm going to do now is turn the timer on. There. And what does that read? 51 volts. Good. That means that the circuit is working. How surprising. So anyhow, getting 51 volts, that's what we want. Make sure I'll turn off this power there. See, that works. 0. Okay, excellent. Good, ready to go to work. I'm not going to connect up this immersion heater element to the power yet, because I need to get some kind of container to put this immersion heater in. I was going to put it in that water bottle there, but that water container, but I can't get to the lock nut on the other side, and I don't want to waste one of these containers, so I'm thinking about using the old water container that was with the vehicle. Alright, got the wood cut to size. Now I'm just going to cut out holes to fit in here. So, and this is all enclosed, so it looks much better and it will be safer too. So it's done. The water pump switch, timer for the heating element, and a switch for the heating element. Looks great.